All right, the next lesson in geometry is called Inscribed Angles. Okay. Recall that a polygon that has its vertices on a circle is called an inscribed polygon. We did that in an earlier lesson in this unit. Okay. Likewise, an inscribed angle. Inscribed angle. Likewise, an inscribed angle is an angle that has its vertex on the circle and its sides contained in chords of the circle. So for example, this diagram right here, angle ABC is an example of an inscribed angle, okay? Because its vertex B is on the circle and its sides, AB and BC, are both chords of the circle, okay? So angle ABC is an inscribed angle, and its intercepted arc is arc ADC. Okay. Now, central angles are equal to the arcs they intercept. Inscribed angles are not equal to the arcs they intercept. Okay. We need to know the inscribed angle theorem. Okay. It says, if an angle is inscribed in a circle, then the measure of the angle equals 1/2 the measure of its intercepted arcs. Okay. And the other way around, you could say the measure of the intercepted arc is twice the measure of the inscribed angle. Okay. So if the inscribed angle, let's look up here. Let's pretend that the inscribed angle was 50 degrees. That means that the arc that it intercepts is 100 degrees. Okay. So here we go. Number 1, find the measure of angle RSQ. Well, let's find the missing arc first, okay? So here's what I'm going to do. All the arcs add up to 360. So I'm going to say that 140 plus 80 plus the measure of arc QR has to equal 360. All the arcs have to add up to 360. That means that the measure of arc QR is going to equal 140. Yep, 140. So let's label arc QR as 140. And now we can get the measure of angle RSQ. Now sometimes it might be helpful if you add some color. So RSQ, the arc that it intercepts, is this arc in blue. Okay, angle RSQ is an inscribed angle, and the arc in blue is the arc that it intercepts. Okay, RSQ. This is the arc that intercepts. So the measure of angle RSQ is going to equal 1/2 of 140. Because inscribed angles are half of the arcs they intercept. So don't accidentally say it equals 140, it equals 70. You can tell it's not 140 because it's an acute angle. Okay, the measure of angle RSQ equals 70 degrees. Okay, so again, inscribed angles are half the arcs they intercept. Okay, so in circle A, the measure of arc AB equals 140. Let's label that. The measure of arc BC equals 100. So this drawing is clearly not drawing the scale, but that's okay. The drawings don't have to be drawn to scale, you know. Same thing with the SATs. Okay. As you can see that BC is clearly bigger than AB, but we're just going by what the directions say. And the measure of arc AD equals the measure of arc DC. So before we can find the angles, let's find those two missing arcs. So since they're the same, let's call each one X. So I'm going to say X plus 100 plus 140 equals 360. Which means that 2x equals, you have 240. So I'll do 2x plus 240 equals 360. Let's get rid of that equal to sign. Okay, now let's subtract 240 on each side. You get 2x equals 120. X equals 60. So each of those missing arcs, AD and DC, they're each 60. So 60 and 60. And again, remember, this drawing is not drawing the scale. And now we can get all the missing angles that we're asked to find. Okay. So the measure of angle 1. Measure angle 2, measure angle 3. The measure of angle 1, that's an inscribed angle. And look at the arc that it intercepts. Look at the arc that angle 1 intercepts. It intercepts arc AD. So it's a 1/2 of 60, which equals 30 degrees. Okay. Angle 2 is also an inscribed angle. It's 1/2 of the arc that it intercepts. So it's 1/2 of 60, which is 30 degrees. Angle 3 is an inscribed angle. It's inscribed in arc BC, so it's 1/2 of BC, so it's 1/2 of 100, so it's 50. Angle 4 is an inscribed angle, so it's 1/2 of the arc that it intercepts, so it's 1/2 of the intercepted arc of 140, which is 70 degrees. And angle 5 is an inscribed angle. The arc that it intercepts is 100 degrees, so it's going to be 1/2 of 100, which is 50. So those are my answers. That example kind of leads into the next theorem. It says, two inscribed angles of a circle, or congruent circles, if two inscribed angles intercept congruent arcs, or the same exact arc, then the two angles are congruent. That should make sense, okay? Let's say you have an inscribed angle and it intercepts a 120 degree angle. Actually, let me rephrase that. Let's say you have an arc, or let's say you have an angle, and it's an inscribed angle, and it's inscribed in a 120 degree arc. Well, then the angle is 60. And let's say we have another inscribed angle that's inscribed in a 120 degree arc again. That angle is also 60. So both of them are the same. Okay. So again, if you look at this example right here. Angle DAC. Angle DAC is inscribed in this arc. And angle DBC is inscribed in the same exact arc. So if they're inscribed in the same arc, then they have to be the same, because they're both half the same angle. Both half the same arc, I mean. Okay? And look at this example right here. You have this arc labeled congruent to this arc. So it means that angle FAE is congruent to angle CBD, because they're both half of the same arc. Okay. Example 3. Find the measure of angle EDF. If you look at angle EDF, that is an inscribed angle, and this is the arc that it intercepts. Arc EF in blue. And look at this angle right here. This angle is inscribed in the same arc. So it means that those two angles are congruent. Okay? Because they both intercept the same arc. They're both inscribed in the same arc. So angle D is congruent to angle G. That means that their measures are equal. So 2x plus 3 equals 75 minus 2x. Add 2x to each side. Subtract 3 on each side. 4x equals 72, which means x equals 18. And now we can find the measure of angle EDF, because that's what the question says. The measure of angle EDF equals 2x plus 3. Okay? And we just established that x equals 18, so 2 times 18 plus 3. That's going to be 36 plus 3 is 39. Let's do a quick double check to make sure we did this problem right. Let's double check x in the other angle. So 75 minus 2 times x, that's the same as 75 minus 2 times 18. So it's the same as 75 minus 36, which does in fact equal 39. So you can do a quick double check by checking the other angle, and you can see that it does work. Okay. Okay, this next theorem. If an angle intercepts a semicircle, then the angle is a right angle. That should make sense, because if a semicircle is 180 degrees, because it's half the circle, well, then the angle has to be half of 180, which is 90. Okay. So we have the semicircle, it's 180. So angle ABC is half of 180, which is 90. Example 4. WY is a diameter in circle X, so find the value of A. Well, I'm going to say since it's a diameter, it means that we have a semicircle right here, so the semicircle is 180, which means that angle WZY is a right angle. You don't have to write that out. I'm just saying, doing it so you see it. So that means that angle WZY equals 90 degrees. The measure equals 90. So I'm going to do 5A plus 20 equals 90. Solve that for A. Okay. Subtract 20 on each side. 5A equals 70. Divided by 5, A equals 14. Okay. Example 5, triangle ABD and triangle ADE are inscribed in circle F with arc AB congruent to arc BD. Okay, find the measure of angle 1, the measure of angle 2, the measure of angle 3, and the measure of angle 4. Given that the measure of angle 1 equals 12x minus 8, and the measure of angle 2 equals 3x plus 8. Okay, so first things first, let's focus on triangle AED. Okay. And you should know that this is a right angle right here because of the theorem right above. Okay. This is an angle that's inscribed in a semicircle, so it's 90 degrees. So I'm going to say that the measure of angle 1 plus the measure of angle 2 plus 90 equals 180, because all the angles in a triangle add up to equal 180. So 12x minus 8. You can probably even skip that first step and just say that the measure of angle 1 plus the measure of angle 2 equals 90 if you want. Okay, but 12x minus 8 plus 3x plus 8 plus 90 equals 180 when you substitute. Combine like terms. 15x plus 90 equals 180. 15x equals 90. X equals 6. Okay. So we have x. Now we can get the measure of angle 1 and the measure of angle 2. So I'll do that over here. The measure of angle 1 is going to equal 12x minus 8. And the measure of angle 2 is going to equal 3x plus 8. So we know x is 6, so 12 times 6. Minus 8. So 72 minus 8. 64. Now let's do the measure of angle 2. 3 times x. So 3 times 6 plus 8. 3 times 6 is 18. Plus 8 is 26. And let's see if that makes sense. Okay, those two angles that we just solved for should add up to 90. Therefore, because you want all three angles in that triangle to add up to equal 180, and we know this one is already 90, so 1 and 2 do in fact add up to equal 90. So I know those are both right by double checking it really quick. Okay, so now let's worry about angle 3 and angle 4. Okay, so again, angle B is a right angle because it's inscribed in the semicircle, so it's half of 180, so it's 90. So that means that the measure of angle 3 plus the measure of angle 4 plus 90 has to equal 180. And you know what? Let's just subtract the 90 now. Let's say that the measure of angle 3 plus the measure of angle 4 equals 90. And there's one thing that we were given in the problem. We were given that arc AB is congruent to arc BD. So therefore, angle 3 is in, so let's just label that really quick. This arc is congruent to that arc. Okay. So if you look at angle 3 is inscribed in BD. And then angle 4 is inscribed in arc AB. So since they're inscribed in the same arc, it means they have to be congruent. So that means they have to each be the same. So they have to each be 90 divided by 2, which is 45. So measure of angle 3 equals 45. And the measure of angle 4 equals 45. Okay. All right. Quadrilateral ABCD is inscribed in circle P. Given that the measure of angle B equals 80. And the measure of angle C equals 40. Find the measure of angle A and the measure of angle D. Okay, so there's a few ways to go about this, okay? Check this out. What's the measure of arc DB? DB has to be 80, right? Do some pencil. Because this is the inscribed angle. So if this is 40, then the intercepted arc has to be 80. Therefore, if that's 80, this arc has to be 280. Write that a little neater. That's a little messy. Okay. So angle A is inscribed in that 280-degree arc. So angle A has to be half of that. Okay? I'm going to say that the measure of angle A equals 1/2 of 280 because that's the arc that it's intercepting. So the measure of angle A has to equal 140 degrees. Okay. Now we have to get the measure of angle D. There's a few ways to get the measure of angle D. Here's what I'm going to do. Since I have a quadrilateral, I'm just going to say that all the angles add up to equal 360. I'm going to find the missing angle. So I'll say that the measure of angle D plus 140 plus 80 plus 40 equals 360. Combine like terms. 140 plus 80 plus 40 is 260. So the measure of angle D equals 100. This is a good problem because it leads perfectly into our next theorem. So let me just label that. Notice how the opposite angles add up to 180. See, 140 plus 40 is 180. 100 plus 80 is 180. That's not a coincidence. That's the next theorem. If a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. So angle A and angle C add up to 180, and then angle B and angle D add up to 180. Okay? Example 7, find the measure of angle CTS and the measure of angle CRS in the diagram below. Okay. So let's start by finding the measure of angle CRS. Okay, the measure of angle CRS equals 1/2 of the arc that, oh, holy voice crack, of the arc that it intercepts. So let's get some color going on here. That's the arc that it intercepts. So if you add up those arcs, you get 194. So the measure of angle CRS equals half of that. It's 97. And now we can get the measure of angle CTS because we know that the opposite angles of a quadrilateral inscribed in the circle are supplementary. So I'm going to say that the measure of angle CTS plus 97 equals 180. So 180 minus 97 equals 83. Okay. Last problem. This is a problem I got from the SATs, practice SAT. Okay, so sorry about that delay. I was trying to do something really quick. I thought I paused the video. Okay, here we go. Let's keep going. Point P is the center of the circle in the figure below. What is the value of x? Okay. So like I said before, this is a sample SAT question. There's a couple ways to do it. So I'm going to show you 2 different ways, and you can pick whichever way you like better if you ever see this problem in the future. Okay? So the first way, let's work off of the quadrilateral that's inscribed in the circle. Well, it's not really inscribed because this is not on the circle, but let's work with the quadrilateral. If this is 20, and this is 20, and this is x, how can I represent angle A right here in terms of x? You can represent it as x divided by 2. Okay, that says x divided by 2. I know it's kind of small, a little messy, but because if this is x, then the inscribed angle is half of x, because x equals the arc that it intercepts. So this arc is also x. Therefore, this is x divided by 2. And then how can you represent this angle right here? You can represent that angle in terms of x as 360 minus x. Because you have an entire circle, which is 360. If this part is x, then this angle is 360 minus x. Now, I'm going to take these four angles, 20, 20, 360 minus x, and x divided by 2, and I'm going to do the following. I'm going to do x divided by 2 plus 360 minus x plus 20 equals, and you should know what they equal. What do those four angles add up to? The angles in any quadrilateral always add up to 360. We did that a while ago. That one you probably have memorized anyway. Let's combine like terms. X divided by 2 is going to stay. The minus x is going to stay. Let's combine all these other terms and say plus 400. Let's subtract the 400 on each side to get the following. X divided by 2 minus x equals negative 40. Now what I'm going to do, this goes back to algebra 1. To eliminate the fraction, I'm going to multiply everything by 2. Okay? So when you do 2 times x over 2, you just get x. When you do 2 times negative x, you get minus 2x. And when you do 2 times negative 40, you get negative 80. Now you're going to do x minus 2x. You're going to get negative x equals negative 80. And then divide each side by negative 1, and you get x equals 80. Okay? So that's one way to do it. Now I'm going to show you another way to do it. In just 1 second. Okay, so here's another way to do it right here. I just recopied the same exact problem. Let's say alternate method. This method is easier, but I think it involves a little more creativity. I'm not sure who's going to think of this right on the spot, but check this out. I'm going to draw something in. I'm going to draw in PA. I'm not breaking any rules here. I'm just drawing it in. What's true about PA and PB? They're both radii, so they're both congruent because all the radii are congruent in a circle. And also PC is also a radii. PC is also a radius. So all 3 radii are congruent. Think back to the Isosceles triangle theorem. Let's focus on this top triangle. Since these 2 sides are the same, it means the angles opposite them are the same. So if this angle is 20, then this angle right here is also 20. And if this side equals this side, so it's an isosceles triangle down here in the bottom triangle, then the angles opposite those 2 sides are congruent. So if this is 20, then this angle down here is also 20. So this entire angle A is 40. If angle A is 40, then it means arc BC has to be 80 because it's 2 times the inscribed angle. Therefore, the central angle is the same. So the central angle, which is x, also equals 80. And that's another way you can do that problem. That is easier than the way we just did it, but this way involves more creativity. I'm not sure how many people are going to think of that right on the spot, but that's two different ways to solve that. Again, that was an SAT question I took off of a released SAT from recently. Okay, and that's the end of that lesson. That lesson was called Inscribed Angles.